In the previous screencast, we looked at how to set up a controlled comparison cross-tabulation. We looked at the relationship between partisanship and gun control opinions controlling for gender. And we discussed how to identify or how to calculate controlled effects and asked whether the controlled effects could be condensed or summarized by an accurate estimate called a partial effect. Let's talk now more specifically about identifying the pattern in that data. And we'll also move on to look at a very different example of an interaction set of relationships. Question: after controlling for gender, is a partisanship gun control opinions relationship spurious? Is it additive? Or is this a set of interaction relationships? Let's review. In a spurious relationship, the XY relationship greatly weakens or disappears after controlling for compositional differences or Z variables. Well, we know that didn't happen because after we controlled for gender, we had very healthy effects of partisanship for both men and women across the values of partisanship. In an additive relationship, the tendency and strength of the XY relationship is the same or very similar at all values of Z. Tendency can also be described as direction. In an interaction relationship, the way you know you've got interaction is that the direction, that is to say tendency, or the strength of the XY relationship is different depending on whether you're on one value or the other value of Z. And these are very asymmetrical relationships. We have one that's really quite symmetrical, and that the partial effects can be used to summarize the relationships. So I've declared that this is an additive relationship. Let's look at why. Now here's a graph of that relationship between partisanship and gun control opinions controlling for gender. This is the percentage favoring stricter gun restrictions. And there are two lines inside the graphic space, one for females, one for males, and both lines travel across, if you will, the values of partisanship. So here are those Democratic females way up there, over 70% favoring stricter measures. And then as you move along the female line, it drops among Republican females. So you get about estimating about a 38-point drop there. Similarly for men, about a 38-point drop across the values of partisanship. The two lines are separated by the gender gap, and we estimated that gender gap at about 15 points, a reasonable, accurate partial effect for the effect of gender on gun control opinions controlling for party. So this is a visual signature of additive relationships. They have a symmetrical calculation when you look at the partial effects, and they have a symmetrical appearance when you graph them. Now let's look at something quite different again, an example of interaction. Here's the setup. We would expect individuals' abortion opinions, X, to affect their vote choice, Y. But we might also expect the XY relationship to be stronger for people who think the abortion issue is very important, or what we call salient. For people who think, for example, abortion is the most important issue, and you have the pro-choice position, pro-life position, among those people, the relationship between abortion opinion and vote choice ought to be very strong, we're suggesting with our explanation. For those who think the issue isn't as important, I mean, we'll still see the signature vote choice on it, but perhaps your relationship will not be as strong. Salience implies interaction. The strength of the XY relationship will depend on salience, which is the value, which is the Z variable in this case. Stronger relationship at high salience, weaker relationship at low salience. Here's the table. It's a controlled cross-tabulation, just like the previous example. In this case, issue salience here, we've divided the data, the sample, into those who give the abortion issue lower importance, lower salience, and those who give it higher importance, higher salience. So that's our control variable. We have vote choice Democratic, Republican, though that's the dependent. The independent variable is comparing those who say abortion should always be permitted with those who think it should not always be permitted. So this would be the strong pro-choice position and less strong pro-choice position here. And then we've done the same on this side for high salience types. Now for this example, let's stick to the evaluation of the effect of the independent variable X on the dependent variable Y, and we'll use a percent vote Democratic at both values of the control. So for the low salience comparison, we're comparing this number among those who found the abortion issue of less salience, but who also believe abortion should always be permitted. 63.2% voted Democratic. And then, quite naturally, as he moved to those who did not hold that position, don't think abortion should always be permitted, only 45.9% voted Democratic. So something's going on there. In fact, we're looking at about if you do the subtraction there, about a 17 percentage point decline in Democratic vote as you move across values of the independent at low salience. But notice this very dramatic difference here. When you switch salience from low to high, go over here on the right side of the crosstab. Now we're looking at people who give the abortion opinion very strong importance, perhaps the most important issue of the day. And among those who think abortion should always be permitted, 82% voted Democratic, versus only about 35%, 34.9%, who do not hold that position. So in this comparison of percentages, you're looking at 82.0 minus 34.9, which is on the order of 47 percentage points, 47.1 percentage points. So what did we find over here? On this side, about a 17-point effect, and on this side, about a 47-point effect. When you get used to doing this, you know when you look at differences like this that you're dealing with interaction here. Why? Because we cannot reasonably condense these two controlled effects of 17.3 and 47.1 into a fair summary of the effect of abortion opinion on vote choice by using a single partial effect. We must keep the controlled effects separate when we discuss these relationships. If you can't condense or fairly summarize controlled effects into one partial effect, then you are almost certainly dealing with interaction. And here's a graph of the relationship we just looked at. You can see the lines cross. Now, as we discussed in an earlier screencast, the lines don't have to cross for it to be interaction. But when they do, it's a dead giveaway that you have interaction. Here's a relationship, Democratic vote at low salience, and again, that's about a 17-point gradient there. There's a difference between those who not always permit and always permit. The percentage goes up in terms of Democratic vote. But it's almost like you reach into this graphic space and switch on some sort of amplifier, and you get this high salience line. Very steep gradient there, about 47 points from here to here. So in this case, we have a clear example of interaction. Why? Because the strength of the relationship, though the relationships run in the same direction, the strength of the relationship is much different at low and high salience, that is, at different values of the control variable.